Here's another example, number 14. In this case, the slope is 0 and the y-intercept is 4. And I really recommend all my students write y equals mx plus b on their paper. I know some students like to moan and groan about, oh, why do we have to do that? But the only way you're going to embed that equation into your memory is by repeatedly exposing yourself to it. So just like I'm listing my givens with the m in parentheses and the b in parentheses because I want to make an impression, a repeated impression in their minds that the y-intercept is the b and the slope is the m, and having them copy this down every time they do a problem, a linear equation problem in that form, is going to hopefully get it to stick in their memory. So put in 0 for the slope and 4 for the b, and one of the reasons I want to show an example of this type of problem is so you can see what happens when you have a slope that's 0. 0 times x is obviously just going to be 0, and that sort of annihilates that variable, and what we end up with is this. So whenever my students see a problem like this or an equation, that a lot of times they don't think that that has an x in it, but the truth is, if you expanded it out, move that 4 over, you'd have a 0x. So this is really an important moment from, as far as I'm concerned, for my students to know. When you see y equals 4, it does involve an x, it's just that the slope is 0. So on the graph, y equals 4, so you go up 4 on the y-axis, and that's our y-intercept right there. That would be y equals 4. The slope is 0, so it's completely flat. Which also explains, this moment right here also explains why this b actually gets to be the y-intercept. Because if you plug in a slope of 0, then the only thing that's going to be left is y equals that, which would be the y-intercept. So that's that type of problem.